Hello, welcome to Chapter 6. We're working on Section 3, Solving Systems by Elimination. In the last section, we were working by solving systems of linear equations using substitution. So this is the next method that we're going to be using. Like I said in that video, we have a lot of different skills that we're going to teach you, and you need to be able to show me that you have learned these skills. It's just different tools in your toolbox, so to speak. So for this first one, we're going to talk through what the steps are. And again, I'll take a picture of this, and you can always go back and have this in your notes. So the first thing is we're going to write the system so that all the terms are lined up vertically. And that means like on top of each other, above each other, however you want to say it. All right. What we're really going to do is make sure that all of the equations are written in standard form. That's usually going to be the easiest. And when we look at it, we're going to notice that most of the problems that we have are going to be given to us in standard form, so that'll be okay. We're going to eliminate one of the variables. And the way we're going to eliminate that is because we're going to add the equations together. And the way that that works is something called the addition property of equality. So if I have an algebraic equation and I add the same thing to both sides of the equal sign, then I end up with something that's also true. I haven't created anything that's a false statement. So by lining everything up in step 1 and adding them together in step 2, we're going to try to eliminate one of the variables, and then that will give us one equation with one variable, and we can solve that, going back to Algebra 1 skills. Once we solve that in step 3, we're going to substitute that into one of the original equations and use that to solve for the other variable. Now, it says to write the ordered pairs of xy. That's fine. We talked about that. But then this part right here, check. Now, we can do two things. We can go back and check using the T-bar graphic organizer is what I was going to say, using the T-bar way of showing things. But there's another way to check, and I'm going to show you that with elimination. All right, so let me start explaining it with an example. All right, so I have x subtract 2y equals negative 19, and 5x plus 2y equals 1. Both of these are in standard form. And if you remember, standard form is something times x plus something times y equals something. All right? So basically, it's one of the three ways that we showed how to show, one of the three ways we talked about how to show a linear function. So I'm going to write this so that everything's lined up. And what I'm looking for, the x's above each other, the y's above each other, the equal signs above each other, and then these constants over here. So I'm going to write x subtract 2y equals negative 19. That's the first equation. I just wrote it the way it was. And then I'm going to put 5x so that the x's are lined up. I'm going to put positive 2y so that the y's are lined up. My equal sign is lined up. And then I've got the 1 right there. And again, if you want, you don't have to, but if you want, you can put a plus right in front of the 1 so that you know that that's positive 1. So now, I'm going to add this way. So 1x plus 5 more x equals 6x. Negative 2y plus positive 2y equals 0. Or you can say 0 times y. And 6x plus 0, I'll put it down here, 0 is just going to be 6x. On this side, negative 19 plus 1 is negative 18. So what I did was, right here, I eliminated the y's by adding the equations together. Negative 2 plus positive 2 equals 0. And when I add 0 to anything, it just leaves it alone. So I end up with one equation with only one variable. So the key for all of these problems is to get the coefficients, which are the numbers in front of one of the variables, in one equation and the other equation to be opposite. So I'm going to write that down. The key, the main idea, is to get opposite, so one's positive and one's negative, coefficients on one of the variables. In this case, it was the y or the y's, but some of the other problems it's going to be the x's. Now, sometimes you don't, this is nice. It started off with negative 2y and positive 2y. So it was nice. It started off with that. Sometimes we're going to have to do something else to make that happen, but that'll be in the other videos. So I'm going to keep working with this because I still don't know what x is. The opposite of multiplying by 6 is to divide by 6. And negative 18 divided by 6 is negative 3. So there's my first part. I've got x, y, and the first part, my x is going to be negative 3. Now I got to figure out what my y is. So I take this and I go back to either of my equations and I substitute. So here's what I'm going to do that's actually not in the book. I'm going to have you do both. By doing both equations, if I get the same number for x in each of them, I'm sorry, for y, because I'm going to be looking for y. If I get the same number for y for both of them, that means that it's going to, it'll be okay. All right? So I know that x equals negative 3. So I'm going to do x subtract 2y equals negative 19. And I replace the x with negative 3. So now I'm going to solve for y. The opposite of adding negative 3 is add positive 3. So I'm going to add positive 3 to both sides. The negative 2y didn't change. Negative 19 plus y equals negative 16. And dividing by negative 2, I get y equals positive 8. Now let's try the other equation. 5x plus 2y equals 1. 5 times negative 3 plus 2y equals 1. Negative 15. 5 times negative 3 equals negative 15. And the opposite of negative 15 is positive 15. So I'm going to add positive 15 to both sides. 2y equals positive 16. And I'm out of space here, so I'm going to write it over here. Y equals positive 8. So that's the same as that. I got 8 both times. That tells me that my solution is x equals negative 3 and y equals positive 8. Move that up so you can see it a little bit. All right. Let's do one more problem before we get to the ones that we have to change a little bit. These first ones are pretty straightforward. So again, I'm going to try to write both of these in standard form. However, it does seem like it's lined up. Usually in standard form, well actually not usually, in standard form, x comes before the y. So if we want to rewrite it in standard form, that'll be okay. Or you can leave it like it is because everything is lined up. It's just sometimes when there's so many steps, we try to go back to what we know. And standard form is something that we certainly know. So I'm going to write 3x plus y. So I just turn those two things around, equals negative 2. And I'm going to put the negative 3x, oops, I wrote y. I'm sorry, I said x, but I wrote y. That's supposed to be an x. Oops. Negative 3x plus 2y equals 14. Positive 3 plus negative 3 equals 0. So that's where the elimination comes from. Those get eliminated. They're opposites of each other. They add up to 0. Y plus 2y, 1y plus 2y equals 3y. And negative 2 plus 14 equals positive 12. The opposite of multiplying is dividing, so I get y equals positive 4. So when I write my solution, I'm going to write something, and my y is going to be 4. Now I'm going to take that and put it back into the original equation. And I'm going to use the original, the way that it's written, so that in case I messed up somehow, and I see how I cut that? I mean, I know it looks kind of weird and stuff, okay? But you see how I cut that? If I left that as a y, I would have messed things up, right? But if I had made a mistake, then I'm not going to be able to catch it if I go back to these where the mistake is. So I'm going to go back to the originals. I have y plus 3x equals negative 2, and my y is 4, so I'm going to put 4 plus 3x equals negative 2. The opposite of adding 4 is adding negative 4, 3x equals negative 6. Divide by 3, and I get x equals negative 2. So I think that that's going to be negative 2. But let's try it in the other one and see if that works. 2y subtract 3x equals 14. This is 2 times 4 subtract 3x equals 14. 2 times 4 equals 8. The opposite of adding 8 is to add negative 8. Negative 3x equals negative 6. Excuse me, positive 6. See, I caught that. I was switching the signs in my head. Positive 14 plus negative 8 is positive 6. And divide by negative 3. And again, I get x equals negative 2. That's the same as that. So I ended up with negative 2 for my x, and my y is 4. Now in the next problem, in the next videos, we're going to have to do something first in order to make these things opposite. We'll see you in there.